Welcome to the final project presentation of CS6963 Digital Forensics. My project is Fotoanalyzer, a tool based on photograph analysis. Photograph analysis is a process of extracting meaningful information called metadata from a photo captured by a camera. Metadata includes digest information, error level analysis, Exif metadata, and color histogram. Based on the information captured by the tool, one can comment on the originality of the photo. For instance, we can say if a photo contains any photo editing tools involved, say Adobe Photoshop from the Exif metadata. This helps a forensicator to generate a report of the evidences which can be presented in the court. Some background about the environment used for the project. Platform used is macOS X 10.10. The IDE utilized is PyCharm 3.4.1, interpreter 2.7.5, graphical user interface is PyQt4 framework. And some information about the libraries utilized in the project. Also the links of references for the project. This project is based on a talk given by Dr. Neil Kravitz during the Black Hat Conference 2007. He classifies 4 ways of analyzing images. First one is visual observation. Just by looking at the images, one can arrive at conclusions based on the objects present in the image. Basic image enhancements like cropping, resizing, or touching the edges, and so on. Image format analysis includes extracting data from Exif tags or XMP tags or IPTC tags or any other tags. Advanced image analysis includes techniques like error level analysis, principal component analysis, and wavelet transformation. So that being said, in this project, the analysis is performed as a step-by-step process. So there are 4 steps involved in the process. First one is the capturing the digest information, followed by error level analysis, followed by Exif metadata, and followed by color analysis. Give a quick background about the steps. The digest information step. It gives a short summary of a file, information like image dimensions, file size, MD5 or SHA-1 checksums. This is the initial step in any forensic examination to ensure whether we are working on the correct file or not. Next step is the error level analysis. Before even going to error level analysis, we should understand the JPEG algorithm. JPEG stands for Joint Photographic Experts Group. They have provided a format for images. It follows a lossy compression technique of digital images, meaning the encoding algorithm of JPEG compresses the images by losing some data, which results in an error. JPEG image is stored in the form of 8 by 8 pixel grids. Each grid is compressed independently. So when each image is resaved at a particular compression rate, it gives us various error potentials. If the image is not changed, all the 8 by 8 squares have the same error potential. If the image is modified or tampered, each 8 by 8 square will have higher error potential than the rest of the image. This gives a way to identify the inconsistencies in the images, primarily giving a way for us to perform error level analysis. Error level analysis is nothing but analyzing the inconsistencies in the images. It works by just resaving the image at a 95% compression rate and evaluating the difference between the original image and the error level analyzed image. So with this, one can find the inconsistencies in the images. There's another important concept called rainbowing. So this JPEG algorithm, it saves the colors not by the RGB values, but it saves by the luminance and chrominance channels. The luminance is the grayscale intensity of the image, and chrominance is nothing but the red and blue components that identify the amount of coloring independent of the full colors in the image. With the resaved images and error level analysis, there may be a separation between the luminance and chrominance channels, thereby giving us a blue, purple, or red coloring called rainbowing. Most of the photo editing softwares introduce a distinct rainbowing pattern that have a uniform coloring, which helps us to identify the photo as being modified or being treated with a photo editing tool. Next step is the Exif metadata extraction. Exif stands for Exchangeable Image File Format. It's a standard for any media files such as images, sounds, and so on. Exif, in particular for a JPEG image captured from a camera, provides a wide variety of information, which includes the camera make and model, focal length, aperture information, or the timestamp, or the GPS latitude and longitude coordinates. There are plenty of free tools available online to check the metadata of images like Exif and XMP. Some of these only support JPEG, while other tools supports multiple formats. There are around 400 plus Exif tags available, but all tools doesn't capture them. Just let us look at some of the free and powerful open source tools. Exif2 is an open source tool that decodes Exif, IPTC, and XMP metadata. It is available as a Windows executable, or the source code is available for Linux and Mac. Exif tool is one of the powerful tool. It's called Phil Harvey's Exif tool. It supports hundreds of different files and metadata formats. It also includes manufacturer specific tags. It's written in Perl language, and it also has a good documentation. Adobe Photoshop's a commercial product that includes XMP Viewer. It's not that great as Exif tool, but it has an intuitive graphical user interface where one can view the XMP, IP, TC, and Exif information. The Exif read library, which I have used in the project, is based on the Phil Harvey's Exif tool, which covers most of the Exif tags. The last step is the color analysis. Color analysis just provides the color histogram. Color histogram is a representation of the distribution of the pixels in an image. For digital images, histogram represents a number of colors in a fixed list of color tones. The color histogram built here is for the RGB color space. Based on the graph, we can analyze for peaks or valleys of color changes, or sometimes it's useful for edge detection. Some of the caveats of this kind of analysis are the error level analysis depends on resaving. For example, if the image is saved multiple times, it results in a blacked out image. Also, Exif tags can be easily removed by editing software which are freely available on the internet. Having said that all these techniques are initial steps in analysis and does not guarantee a conclusion. Some of the applications of this kind of analysis are in the media, where we know most of the images in the media are being altered, or it gives us intuition that whether they are original or not. So it allows us finding fictional images. In the legal area, it is most useful for detecting the child pornography, or finding out virtual child pornography, which is legal in the United States. It's also used in authentication. For example, some of the systems utilize a photograph with a credit card or a name board as the authentication mechanism. So in that way, people change the card, just copy the image, change the card, and here's an example of how it is done from Hacker Factor. So they just change the card which the person is showing, and the system just authenticates them. The conclusion is, although this tool is not sufficient to conclude if the image is tampered or not, but it serves as a basis for advanced level of forensic analysis, because error level analysis is a perfect way to start analyzing inconsistencies in photographs under certain conditions. There's one article, a recent article about a photograph which is given a prize in World Photo Awards contest, and some forensic experts claiming that it's a fake photo. So this image gives us the ELA version of the actual image, where we can see the rainbowing effect, which is clearly visible on the walls, also on the sky, and in some of the people. But it's a controversial article. Please have a read just by clicking on the link. Also, additional research going on in this topic. And also, there are commercial tools available to analyze the photographs. Listed below are some of the free tools available to analyze photographs. One is Photo Forensics, which allows error level analysis online. Jeffrey's Exif viewer allows us to view the Exif metadata tags online. JPEG Snoop allows us to identify fake images based on signature analysis. Also, iExif 2, it's a professional Exif viewer for Windows. Let's jump into the project demo. This opens up the tool and selecting the file which needs to be analyzed. So I'm selecting the as I've mentioned in the explanation, it's a step-by-step process. First I'm going to find the digest information. Well, this gives the file name, file type, dimensions, width and height of the image, and also the file size in bytes. Also it gives the MD5 SHA-1 and SHA-256 hash checksums. One can match the checksum received for the image with these, and find whether and make sure whether they are working on the actual image. Next step is the error level analysis. So the left pane is I've displayed the original image. Right plane displays the error level analyzed image saved at a quality of 95%. So just in case you're not able to view the inconsistency, just you can adjust the error scale or resave the image in a different quality and analyze. So clearly one can see the inconsistency here. It's the text about the photograph which looks odd here. The error potential of this text is quite different, so that's an observation which says that this text might have been added after taking the photograph, or it might have been just copy pasted. Let's go to the next step. Exif metadata analysis. So this captures the Exif tags provided by from the Phil Harvey's Exif tool. So by looking at the Exif tags, we can find the information regarding the camera make. As I have mentioned, the camera make is Canon, white balance, auto resolution. The important information here is the image software. So image software, it says Adobe Photoshop CS Windows. So which clearly says this image has been opened with a Photoshop tool with chances for the image being edited. Next analysis is the color analysis. Let's have a look at the article. Yeah, this is the image which I was mentioning, awarded in the World Photo Contest. So forensic experts are saying that it's an edited image, or a touched and color changed image, but it's a controversial case where different people are saying different things. This is the actual image, and this is the image which is submitted by the participant in the contest. Just by observing the photographs, the color of the image submitted, it looks different. Also the walls, the texture of the walls are a little bit different. This is a competition conducted by World Press Photo Organization. Yep, there we go. So this is the color histogram which I was mentioning in the explanation. This actually gives us the color tone in the x-axis present in the image versus the number of pixels in each color tone. So for this image, we don't see any peak in the graph. Also, there are no inconsistencies in the graph. So with all these analysis, we captured various evidences like the Exif tag saying that Adobe Photoshop software has been used, and also the error level analysis image, which clearly showed us the inconsistency. So collectively, with all these evidences, we can say that this image is an edited image, and this can also serve as a basis for performing advanced image manipulations like wavelet transformation or principal component analysis. Thank you.